We're going to be simplifying and evaluating. The evaluating will be next week. Using properties of logs. Now, one of them is not on here, so I'm going to write it up in the top corner. And I would encourage you to write the same. It is the inverse property, and then we're going to use it on the first two examples up here above the box. So the inverse property of logs, so you'll notice on both of these, what's the same characteristic for both A and B? What's the same about both of them? The base value is the same as what's called the argument, that came up the other day, but that's the bigger number next to it. So that is when the inverse property applies. So the inverse property is when you have the base matches the argument, and then you'll have some exponent. So I'll just pick letter M. You can use whatever letter you want to. But when the base matches the argument, which is the bigger number next to it, those actually eliminate each other. So the log of base B and the B eliminate each other, leaving just the exponent of n. And I will elaborate on that further as we learn these other properties down here. But when the the log of the base matches the argument, they eliminate each other, leaving the exponent behind. Now, if the exponent's not there, it's a 1 automatically. Okay. So for A and B, this is going to occur. So since this is log base 9 of 9, yes, it's squared, doesn't matter. The log 9 and the 9 eliminate each other, leaving the exponent of 2 behind. So 2 would be the simplified expression for that. Okay. What about B? Just 8. Now this property shows up within the other properties that we're going to deal with, so this will come up periodically. So we will have to check to see if it's appearing based on the numbers that are there. Okay. But no matter which properties we use from the other ones, this one will always apply. So that's called the inverse property. Okay. So any questions about that? Okay. Now the primary thing that we're doing today. So logs can be multiplied, divided, and can have powers. So there's 3 properties. Now you will be going back and forth on these. So if I take it from, for instance, multiplying into adding, I'm expanding it. You'll notice it went from 1 log expression to 2. That would be expanding it. Versus if I went from the addition back to multiplication, that would be called condensing. So you will be going both directions. So if you are expanding, if you have log base anything with 2 arguments being multiplied together, that would expand into 2 separate logs added together. And again, we're going to do these. So I don't expect all the letters to make a ton of sense right now. But multiplication expands into addition. Separately, if we were to condense an expression like this down, it would condense into a single log by multiplying. Okay. So these will expand here, or they will condense backwards. So they will go forwards and backwards depending on what your instructions are. Okay. We're going to do several of these. Division is the opposite. So multiplication becomes addition when you expand. Division becomes subtraction. Now it's always the numerator of the division is the first argument, and it'll be subtracting the log of the second one. Vice versa. If you're going from subtraction into division, the first term is the numerator, the second argument is the denominator. Okay. So we're going to be going back and forth between the two. The power property, just because that exponent's a little bit smaller, I'll zoom in. This is the condensed version, this is the expanded. What the exponent does is it goes out front of the log here when it's expanded. Now if you're condensing, there will be a number in front of the word log, and you will put it back as an exponent on the argument. So we're going to be combining some of these, they might all be in the same problem, okay, depending on what you're doing. So there's many different types of these, but these are the base properties you are using to either expand or condense. Okay. Now we're going to start off with a couple. So after we do a few, it might make a little bit more sense. But again, there's a lot of types of these. So when it says write each expression as a single logarithm, so that is condensing it. So taking it from its expanded form and making it a single log instead of 2 in this case. So it's currently subtraction, which means it's going to change to what? Division. Okay. So on C, we're going to change it to a single log of base 4. And and then it's going to be of a fraction because it's division. The first number, which is 32, goes on the top of the fraction, and then the second number goes on the bottom. Now, if you can reduce this, you do need to. Does 32 divide by 2? It's 16. Okay. All right. Now, sometimes you get here and you're done. In this case, we are not because of that inverse property at the top. It only is going to occur when you have two different numbers. If there's variables involved, like you'll notice the next one has x's and y's, you just condense it and you're done. But if you have two numbers, if you can make the 16 match the 4 in the base, so can 16 be written as a power of 4? Yes. So if it can, you will need to convert it into that. That is not always the case. Okay. So if I turn the 16 into a 4 squared, so I just adjusted that. So this became this. And by that inverse property at the top, what happens? The log 4 cancels out the argument of 4, leaving the answer to be a 2. So all of that came down to 2. But that is an application of two different properties. The division one and the inverse property. Now if that was a 4 and a 15, you're done, because 15 cannot be a power of 4. So it just depends on the numbers that you have. So if you can make this number have a base that matches that, you will need to. If not, then you're done. Okay. So it's going to vary. There's a lot of different types of these. Question on that one? Okay. Now this one has two properties. The addition side would be the multiplication. What's the other one that's occurring? The power property. So there's a 6 in front of this one, there's a 5 in front of this one. Move those first. Okay, so those are going to become the exponents, so that's the power property. So the 6 will be attached to the x, the 5 will be attached to the y. So they're just being put back. Do that first before you combine them into one log. So that'd be log base 2 of x to the 6th plus log base 2 of y to the 5th. Now adding, when we condense into a single log, becomes what operation? Adding becomes multiply. So this would be log base 2 of x to the 6th times y to the 5th. You can put parentheses around that if you want to, but that would be your ending result. So that was both the power property and then the product property in the same problem. So those are just two examples of condensing. Sometimes it's just put them together and you're done. Okay. But sometimes you're going to have multiple properties. Questions? If you're confused, you got to tell me. Okay. Now expanding, so we're going to take it from one log into at least two, sometimes more than that. Okay. So on E, it's in a fraction form. I want you to split apart the fraction first. So what operation would that be? It would go from division into what? Subtraction. So split apart that fraction. Now the numerator will go first minus the log of the denominator. Okay, so start there. Get rid of the fraction. Now you'll notice there's no base. We're going to talk about that in a few minutes. If there's no base, then just leave it that way. There's one value that doesn't have to be written. So it'd be log of 4x minus log of y. Okay. Now we are not finished yet. Can anyone tell me why? Is there anything else that can be split apart? The y is a single argument. That one is done. This is 4 times x. What is multiplication split into? So this is two different arguments. So yes, so this would be this portion over here, log 4x. That's the first one up here. So it would split into log of 4 plus log of x. So you have to expand until you can't anymore. So first you would have log 4 and then plus log x and then just tack on the minus log y. But you have to split up the fraction first before you do that. So you should only ever have one argument when you are expanding. You should only ever be one thing there. Okay. So this is our answer on that one. So you expand until you cannot expand any further. Questions on that one? Now, if I were to put this back, just as a side note, I would just go left to right. These two are adding, put them back into multiplying, then put it back into a fraction. So if you were to condense this back down, just go left to right in sections. All right. You guys tell me, what are we going to do first on this one? Subtracting. So log base 9, x to the 4th, bless you, minus log base 9 of 729. All right, so starting with the first log, why are we not done? The exponent. Okay, so this is the power property to start with. The 4 is going to go in front of the log. So you're almost like taking these apart into its smallest pieces, is what you do when you're expanding. So the 4 will come down in front. Now this first one's done. So 4 log 9x. So when you're expanding, you should have no exponents and only one argument in each one. Now, can we simplify log 9 of 729 any further? When this is just a number, you have to check if I can make it a power of 9. Can I? It's 9 to the 3rd power, so yes we can. So minus log base 9, the 729 becomes 9 to the 3rd. So you only have to check that if that's a number with the base next to it. Okay. If that was any number that was not a power of 9, then you're done. Okay. But you have to keep going as long as you can. So what happens now? The log 9 and the 9 cancel out, leaving the 3. Now the reason that it's a whole number 3, I'll explain here in a second. So 4 log 9x minus 3 would be your answer. The reason it's a big 3, okay, is just like this 4 exponent came down front, technically that 3 would come down in front as you're doing that. So that's why it's a big number 3. Okay. But we didn't learn that property yet when I first introduced it to you at the top. Okay. So that's why it becomes a whole number versus just an exponent, because it's being expanded. Now I could give you examples for like an hour because there's so many different types of these. I'm only giving you a couple of each type. Your homework is almost like more examples of that because there's so many different combinations you can have. So is there any questions on any of these 4 that we've done? It takes practice. Eventually we're going to be solving. You're going to have an X somewhere that you're going to have to isolate. So that will be Tuesday of next week. But you need to know the properties pretty well before we can do that, because you would apply the properties when you're solving. Okay. Questions before we talk about the very end of it, which is kind of unrelated? Okay, so down here, this has something to do with what we learned on Monday when you were first introduced to logs. So we've seen logarithms with a lot of different bases. The log key on the calculator finds log base 10 of a number. Now up here where we didn't have a base, those are automatically base 10s. So if you ever don't see it, that's a base 10 automatically. So to evaluate a logarithm with any base, let's say we had a log base 4 of something, you can evaluate it in a calculator as well using change of base. Now we did this the other day by hand. Okay. So let's make up one. So if I had log base 6 of 36 equals y. We did this the other day. You had to convert it into exponential form, which would have been 6 to the y power equals 36. What would your answer be? 6 squared would be 36. So the y value would be 2. Now, if that was, let's say, 35, does any power of 6 equal 35? No. So this is where a calculator would come in because there's still a value for that. It's just going to be a nasty decimal. So if you have any different base, okay, other than 10, the calculator can do that. You would take the log, and I'm going to show you how to do that on the next two, the log of the argument, which in this case would be m, divided by log of the base. Okay. So on these, so we're going to use the calculator here in a second. You have to use parentheses around each number log. So we would do this in the calculator as log of 27, because it does log base 10. So this is log base 81. So this is our way around it. So we do log of 27 divided by the log of 81. Now you're going to have to put parentheses around it in your calculator, otherwise it's not going to do it properly. Okay. So in your calculators, do you see where the log button is?
Yeah.
Where?
The tens power next.
Next to the 7. Okay. So log, you'll notice it opens a parentheses. So 27 in our case, close the parentheses or it's not going to do it right. Divided by log of 81, close the parentheses. Okay. Now that's a fairly nice decimal. What is that as a fraction if we have it right? 3/4. What that means is 27 and 81 can be written as the same base. They can both be base 3s. So we could have figured this one out by hand, but the calculator would give you the same. Okay. So this would be 0.75 or 3/4, whichever way you want to write it. But that's because we could have changed these both to a base 3 to make them match. However, I cannot make a 5 and a 36 match bases. So this one's going to be a different decimal. So we would enter this into the calculator as log 36 divided by log of 5. Okay. So basically, the change of base formula is converting them from a base 5 into two separate base 10s, because that's what a calculator does a base 10. Okay. So log of 36 divided by log of 5. Let's go nearest hundredth. 2.23 approximately. And this would be because I cannot make a 5 some power to equal 36. At least not a nice one. Okay. So that kind of ties in, that's kind of a little separate entity, but we'll use that here and there as we move through the rest of this chapter. But that more so ties in what we learned on Monday. If you can make them the same base, you can solve them by hand. But if not, the calculator is available. But I did need you to know where these numbers are even coming from in the first place, which is why you had to do it by hand the other day. Okay. So, your homework is over these. So is there any questions on that? Again, there's a lot of different types of these, which is why I don't have very many examples. I can do examples upon examples upon examples, but until you keep practicing them, it's not going to matter.